Welcome to Vaadin webinar about scalability. My name is Matti Tahvonen, and I'm pretty sure that you know my special guest, Arun. Hi.
Hello there.
Arun is a famous speaker in Java EE world, and you have most likely heard him on some conferences or read his book, or at least you have probably Googled some of his technical documents. That there are thousands of them on your blog. I have at least. Each time I type something related to Java EE, it's always Arun's blog.
Well, it's an honor. Yeah, I've been with the technology for many years now, so it's a joyful ride.
Yeah, but this year has been something a bit different than the last 10 years. You have changed employee. You are now in RedHat.
That's true. That's true.
Yeah.
So I was part of the founding team of J2EE. Started back in '98 with Sun Oracle, and last year I switched roles. Now I'm the director for developer advocacy at Red Hat. So pretty much doing similar job, but in a lot more fun, free atmosphere, and more importantly, where community is heavily valued, and engaging with them is very critical for us. So really enjoying it.
Yeah.
Well, I got a question for you too.
Okay.
I hear that, well, you were telling me that you have switched your roles recently. You know, you were on the dark side.
Yeah.
Now you're coming on the brighter side.
Yeah, I have been actually doing product development here in Vaadin for like seven and a half years or something. But now I'm doing pretty much the same that you are doing.
All right. So
but I'm emphasizing Vaadin, not WildFly.
Right. Well, today the audience is going to learn about Vaadin and WildFly.
Yeah.
You got your 7-year UH complete. So now we can talk about the webinar. Excellent.
Yeah. Okay. And Java EE, Vaadin, and WildFly, they are all kind of proven technologies. So what we are going to discuss today is about some pitfalls that you may face when building scalable applications, and how you should do it, how you can test your application scalability and profile it and find out the weak points there. And then we had also an exercise application where we build a kind of a very interactive modern application using WebSocket communication, Vaadin UI, and WildFly. And we wanted to prove that really scales, because WebSocket is a very new thing. It's not that well optimized in, for example, load balancers. So there are lots of things that we learned actually there,
right? And
we will share some experiences from that exercise.
Yeah. Well, we hope that you learn from this webinar the tips that you can apply in your applications into production.
Yeah. Okay. So what is Vaadin? Yeah, there are probably some fellows who are coming from WildFly world or Red Hat world, and they don't probably know what Vaadin is. Vaadin is a Swing-like kind of component-based UI framework for web applications. So you will be coding like a normal desktop application using Swing, but the output will be just a normal web application. But you don't need to concentrate on anything related to web actually. So you don't need to think about how you communicate from the browser to the server, or you don't do, nothing related to HTTP, JavaScript, HTML, or anything.
That's pretty nice. Yeah.
So it's plain Java, and no browser plugins, so you don't need any Flash plugins or anything. And for example, with WebSockets, which we are talking quite much today, you don't even need to use the WebSocket API that you presented in Java EE7,
right?
But you will just enable push in your Vaadin application, and then you can do some dynamic changes to your UIs, and then the changes are reflected automatically to the client, and the developer don't actually need to worry about WebSockets at all. Everything just happens.
Right. So I think although WebSocket provide a low-level API, but abstracting it, dumbing it down basically to a developer is very critical.
Yeah. And the thing about Vaadin is really developer productivity. We do it very easy to make and very fast to develop Vaadin applications compared to normal web application development, where you have lots of moving parts and you need to think about the network and some HTML tricks and stuff like that. But with Vaadin, we value more productivity than scalability, for example, but it still scales.
All right, very cool. Okay, now for people who are new to Java EE, Java EE 7 was a new release, the latest release of the platform, which was done last year of June. There are lots of new components added over there. The first and the foremost one being WebSocket API, which is built as JSR 356. So it's abstraction, how you can build a WebSocket endpoint using Java EE 7, just an annotation on a POJO, and that's a WebSocket endpoint. You can build a Java-based WebSocket client endpoint, just another annotation once again, and how easy it is to do all of that magic within Java EE 7. Another new terminology or technology that was added to Java EE 7 was batch application. So you can say, I want to build a batch application which is run at a regular interval. I want to read thousands of records, validate them, and process them, and write them to a database. Multiple input sources, output sources, a very clean API derived heavily from Spring Batch. A low-level JSON processing. So JSON has become the lingua franca of the web. So it's a low-level API, but it is a very good start as part of Java EE 7. And we see a lot of customers using it primarily because they don't need to rely upon third-party libraries anymore. That's JSR 353. Last but not the least, concurrency utilities, where you can spin up user threads in a managed environment, so which was not permitted earlier. This is, again, a lot of excitement around Java EE 7.
Yeah.
I've been around Java EE pretty much all my career. I've never seen such an excitement around the platform, so which is pretty cool.
Concurrent utilities, that's especially very handy for Vaadin developers, because Vaadin developers are usually creating highly dynamic web applications, and there you will probably need that background thread doing some task and then notify the client.
Exactly. So this really adds to what our theme is, which is building scalable applications. Yeah. So there are a lot of functionalities in Vaadin, in Java EE 7, and WildFly, which we'll talk about shortly. So what is WildFly? Well, WildFly is fast. It starts up really fast. The runtime is very fast. It's a lightweight application server. The disk footprint, the memory footprint is very light, extremely manageable. So there is a command line interface, there's a web interface, there's a REST API, lots of different ways to manage it.
Yeah, and it's pretty modular.
Very modular, actually.
Yeah, so you can get the basic set of features very fast up, and then if you need JMS or something more advanced, then you can use the full profile.
That is correct. Full platform, or you can start adding custom modules very easily that way. Extremely developer friendly. Now, you said developer productivity is key. If your product is not developer friendly, I'm sorry, nobody's going to use your product. That is very, very key. And last but not the least, all the Java EE 7 technologies that I talked about, WildFly is a Java EE 7 compliant application server. So how do you build and deploy a WebSocket endpoint? You do that in WildFly, basically. It's also the upstream version of JBoss EAP, which is our commercial offering. So WildFly doesn't have a commercial offering yet, or WildFly 8 at least doesn't have it. Just going to come as part of EAP 7 in the next few months. This is what used to be known as JBoss Application Server. It's a very important change because now WildFly has its own life cycle where it can evolve in 9 to 12 months. EAP is a lot more conservative brand meant for production deployments, where it evolves every 2 to 3 years. So just a quick change you need to know. One of the cool things which allows you to build highly scalable applications as part of WildFly, which is going to be in EAP 7 as well, is Undertow. It's a brand new web server. Up until WildFly, our web server was based on Tomcat, but now is Undertow, using lots of new APIs, JDK and IO2 APIs. And Tech Empower, is a website which runs these benchmarks across different frameworks, as they call it. Jetty is a framework, JSF is a framework, Spring is a framework. They consider Undertow as a framework as well. So they've been able to use 4 million plus text entries being processed back and forth per second.
Yeah,
that's pretty cool.
Yeah.
And if you want to do JSON processing, they've been able to do about close to 1 million JSON entries per second. So that's super impressive. So just to give you an idea of if you're looking for building scalable applications, why WildFly is a great choice. Last but not the least, easiest way to get started with WildFly is, well, you can download it, start with it, run with it, that works. But if you don't want to do that, then OpenShift is a Red Hat's PaaS offering. You can go to openshift.com, create your account, click on a link, and just run up a WildFly instance up in the cloud. absolutely free, no money charged. And we'll talk about some of those setup issues that we encountered as part of this application development.
Yeah, then let's go to the real meat of this webinar, so scaling. And we have actually collected some notes that you should, what you should think of scaling, what is scaling. And this slide actually has some points that are kind of both for vertical and horizontal scaling, how scaling is usually divided.
And we will explain what vertical and horizontal scaling is.
So common things are that you want to configure, for example, is JVM settings. So make sure that your JVM is using the resources of your host machine as efficiently as possible. So most likely you will be modifying your XMX setting. So heap size and also garbage collector.
Right. So one of the cool things to remember is that with JDK 8, heap is gone.
Yeah.
So you're basically specifying XMX and XMN.
Yeah.
There is no heap size management, which is pretty cool. Auto heap, take care of it. I just want to stay back.
Yeah. And then optimizing your application, kind of, because your application scales much better if it can handle more requests with the same CPU or with the same memory. So
yeah, footprint is very, very critical because what is your static footprint of your application, which is sort of your fixed cost, and what is the dynamic cost of it, like in case the application needs to scale up or scale down.
Yeah.
Another critical part is if your application is stateful, then you have a session size in there.
Like Vaadin applications.
Yeah, Vaadin application, Java EE applications, any of those, HTTP sessions, EJB sessions.
Yeah.
There are lots of different sessions. So as part of capacity planning, you need to be aware of how big your session is. If you're creating a cluster, how much memory is in the machine. Is your memory enough to handle, it may be enough to handle 100 concurrent users, but is the memory enough to handle 100 concurrent user sessions?
Yeah.
So that becomes basically your bottleneck in that case.
Yeah. Then network. If you have lots of unoptimized images, for example, you might get a lot of static simple requests that are easy to serve, especially with Undertow. But still, it's the big image that you are serving to all users that might actually use all your network.
Right.
So then you will get a big latency with the real requests that are going for the application. So
another key part of network is, let's say if you're reaching out to some third-party software,
yeah.
What is your timeout issues? If you're calling a third-party service, and that's where your concurrency utilities would be very helpful. So spin up an extra thread, let the thread do the background processing.
Yeah.
Once
then
you receive the response,
user interface doesn't jump, but it's
exactly.
You can show some notification that this is going to take a while.
So it's very important to build that responsive user interface in that sense.
Yeah.
Another critical part is CPU utilization. So we talked about memory, the network, session, all of that.
Yeah.
But is it a CPU intensive exercise?
And also, can CPU really work?
Right.
If there is concurrency issues, then it might be that your CPU is practically idling, but still the requests are taking long.
Right.
Yeah.
Right. Caching is another critical concern. How quickly do you respond back to your users? What is the eventual? Is it eventual consistency? Is it always consistent? So think about, you want to go to the RDBMS route, NoSQL data structures route. What's sort of your philosophy around caching in general?
Usually, in all application, database is going to be the first bottleneck. That's pretty much always.
Right.
So caching will be very good for database. For example, using a second level cache in JPA, for example, InfiniSpan can be configured there. And then you will, for normal GET requests or reading the data from the database, you will most likely then not hit the database, and it will have more powers.
Right, and the good thing is that if you're using WildFly, then you get InfiniSpan for free anyway. And we'll talk about different...
You just enable it and then it's there.
That's it. And we'll talk about strategies and how you can scale it out to a different tier altogether to get a much higher level of scaling. Another important point to us is very important is when you want to scale your application, sometimes it could be limited by the number of logging that you're doing, amount of logging you are doing. Make sure your info, debug, find, finer, finest, those messages are set at the appropriate level.
Yeah.
Display the information that is really required for the user don't dump everything into like, info bucket.
Yeah.
Because then the more logs you are generating, it's going to slow you down a little bit, minimal, but think about hundreds and thousands of users connecting to you, and that becomes a bottleneck right there itself.
Yeah. And then about all these things that we have listed already, what's really going to be the thing that limits your application to scale better? That's the thing that you should find out, because you will quite easily spend lots of hours optimizing the wrong place. So always try to replicate the real world setup that you will be using in your hosting. So have the same load balancer, have the same CDN, have the same application servers, and configure them in a similar manner, and then test.
Right. Well, I mean, as they go with the TDD philosophy, test early, test often.
Yeah.
It should be scale early, scale often.
Yeah.
So you should incorporate, like, typically in an agile model, you have like a 2 weeks of sprint. Incorporate that scalability testing early in your cycle.
Yeah.
If you want to have, you don't want to say, okay, now I build the entire application, now I'm going to look at scalability.
Yeah.
You may even have to re-architect, rewrite significant pieces of your code, which is very, very critical.
Yeah.
And so, as you were saying, profile for bottlenecks early on. Think about what is your expected user load, you're looking at it, and start profiling your application. Figure out, is database the bottleneck? Is the query the bottleneck?
Yeah.
Is JPA the bottleneck? Is Hibernate the bottleneck? Is the session size the bottleneck? What are those potential bottlenecks? And then start optimizing that piece.
Or don't start optimizing if the performance is adequate without it.
Right, as they say,
Because this will be very, very expensive doing these optimizations, and also scaling out with horizontally. That's going to be expensive. So if it's performing good enough, don't do anything.
Yeah, premature optimization is of course evil.
Yeah.
So you don't want to do that.
Yeah. Scaling is pretty much optimization. Right. So that rule really applies to this as well.
Yeah. So let's talk about vertical scaling. I love sports analogies. So to me, Usain Bolt is like vertical scaling.
Yeah.
He's
fast.
He's fast. He's by himself super fast.
Yeah.
And how he became faster. If you look at his workout regimen, he is doing push-ups, the amount of lunges he's doing,
that man has been optimized well.
Absolutely, yeah. I mean, he's been winning gold medals in Olympics all the time. So go back to Olympics. The logo is Citius, Altius, Fortius. So faster, higher, and stronger.
Yeah.
So vertical scaling, to me, that summarizes what it is. Basically, it means you want a vertical scale. So you got one box. You want to vertical scale it, throw more RAM into it.
Yeah.
4 to 8, 8 to 16, 16 to 32, 64, however it can handle.
Yeah.
And
that's an easy and cheap trick.
Well, the important part to recognize is if it's a 32-bit or a 64-bit machine, you don't want to install 64 gig RAM on a 32-bit machine. You won't be able to leverage it.
Yeah, but with 64-bit machines, that's not a problem.
Then there is you can really go high. Similarly, is the CPU good enough? Get a faster CPU, better disk, instead of going.
CPUs.
Yeah, go for a SSD, that will give you a better one. But the idea is everything is confined within one. Application, what are the bottlenecks in your application? Algorithms, what algorithms are you using in your application? So pretty much everything is confined within that box.
Yeah.
You can tune operating system, JVM, application server, but all within one box.
And then horizontal scaling. That's on the other hand, adding more machines to your system. So you will be, there is kind of two strategies. The first one is to specialize machines to do one specific task. For example, if you have lots of static files, small files that are usually quite common nowadays in HTML5 applications, you have CSS files and some small images and stuff like that. Maybe, Undertow is quite fast, but it's still not necessarily maybe to serve them through your application servers. You can use CDN servers or CDN services,
right.
Or then you can build kind of your own CDN by having some specialized machines that are only serving these small files. And then, CDN. Then, for example, you can make mashups. For example, you can have your, for example, if you're having a website and you have just slightly dynamic content there, and then you want to serve one part of that page with Vaadin application, you can also serve that one part from a separate server. You don't need to, if you have, for example, you might have some hosted service for your website, then you might not be able to serve any real static or really dynamic applications there at all. Then you could just embed it there, the Vaadin application, and serve it from a different server. Then you have one for the website, one for the application, and combine them into one page.
So in general, if you are accessing a web page, it does not allow you to go across domain and get the resource sharing.
Yeah.
But that's what we're talking about, codes here, basically.
Yeah. You could do it with iframe. That's how it has been done earlier. But nowadays, Course is very well supported among the more modern browsers, so you should definitely use Course now.
Right. So
there is actually one very recent blog entry in Vaadin.com made by Sami Ekblad. There's a good instructions how you can make your Vaadin application Course compatible.
Excellent. Yeah. I mean, I was watching the traffic on the JAX-RS expert group because they're looking at the next version of it, and there is already a request on actually enabling Course in JAX-RS itself.
Yeah.
So yeah, I mean, this is pretty much getting very prevalent these days, and that allows your application to scale much better as well.
Yeah.
Business logic, I mean,
this is your expertise.
Yeah, because this is where you actually put your application. What is your EJB? What is your JMS?
Yeah.
How do you scale it? How does it run across different application servers?
Yeah.
You can split up your applications, have like 4 application server instances. So typically when I talk to customers, they say, yeah, we got multiple instances of JBus EAP running in the background, each hosting the same version of the application.
Yeah.
And with WildFly particularly, you can easily configure it how it can fail over the session so that if one server goes down, not only you have application availability, but you got session availability.
Yeah.
So that's pretty cool. Well, we talked about session replication already.
Yeah.
So not just application scaling, but database scaling.
Yeah. That's pretty easy job also. Usually just configure it to use TCP connection to the database and move it to the different. This is probably the easiest thing that people do with horizontal scaling. They will have the separate database server.
And even in that, there are multiple mechanisms like master slave or sharding.
Yeah.
And there are certain database specific features as well. People leverage it because this has been known to happen for a good time actually.
Yeah. And then there is clustering. So in clustering, you will have those machines doing the pretty same stuff, but you will have lots of the machines doing it in parallel. So for example, for web applications, you will have one user going to server 1 and one user going to server 2.
And those are like sticky sessions basically.
Yeah.
So if a user has gone to a particular server, he's always going to that server. But if that server happens to fail, then it's going to fall back on a different server.
Yeah. So typically in clusters, there are some kind of shared memory possibilities so that you can, for example, rely on this session replication.
Right. And those session replication work for whether it's HTTP, stateful session bean, JMS, InfiniSpan. InfiniSpan is the way by which you provide that shared memory, for example, in WildFly.
Yeah. So because they are working as a cluster, then it's pretty easy. It's not as easy as in one server, but it's pretty easy to make a kind of look like a one application to the outside world.
Right. And I think one of the things we were talking about also is we are doing horizontal scaling with multiple machines. Each server could vertically scale within itself.
Yeah.
So, but one of the ways we do scaling also is by doing multiple WildFly modes. So, for example, you could start up WildFly in a standalone mode where it's a single instance of WildFly. Or you can say, I want to start up WildFly in a domain mode, which makes it centralized administration much easier. Now, both the standalone and the domain mode could be configured for clustering.
Yeah.
But in standalone, you're on your own for session replication and things like that.
Yeah,
for domain
deployment,
all of that. But in domain mode is a lot more simpler in that sense.
Yeah.
So there's a HA and a non-HA mode. So look at the combination of standalone, domain, and HA and non-HA and see what serves your need.
What your application needs.
Right.
You don't necessarily need all the features. But
Right. So it's very, very customizable in that sense.
Yeah. But with clusters, then you have the problem that you have server 1 and server 2, and they have different addresses. But for the outside world, you would only like to have one address where your applications are going. there are a couple of strategies to pass this. One is of course using DNS hacks, so that you have like for European users going for one server and US customers going for one server, or then you could have some kind of round-robin algorithms in DNS. But quite often they are also, the cluster is front proxied with a load balancer.
Right. That's the typical more common approach, and it could be either just a hardware load balancer like F5, or any of the software load balancers like Apache HTTPD, Nginx, or any of those, or HA proxy, which is what we're going to talk about today a little bit later. Or a combination of a hardware load balancer plus a software load balancer, and see how they work out.
And
also
combinations of DNS load balancing and load balancer.
Right.
So this is kind of a typical setup that might be for big business applications. Then the first thing that you want to do is probably to move these stupid files to the CDN.
What are those stupid files?
So these are these JavaScript files that nobody understands, and HTML and images and CSS and stuff like that. Those are static files that never changes practically.
Those are dumb files basically. They just stay like that.
Then the real stuff goes to the application servers. They go through the load balancer, and then they split to a cluster of WildFly instances, and all these WildFly instances connect to one database URL, and behind that URL you might have one database server or maybe a cluster of database if you have like a master-slave system. Then probably you can optimize the reading from the database if you have a cluster, but writing is usually harder to optimize for the database because there needs to be some logs.
Well, the cool thing is WildFly has Undertow, and if you have your static files, you can configure Undertow to be sort of your CDN as well. So Undertow could be configured in that mode where it automatically serves the static files for you, and any dynamic logic, so to say, is served by the behind application server. So which is pretty cool.
So it don't need to go to the servlet at all then.
So static files are served right by Undertow, and if you invoke servlet, EJB, anything of that sort, then it goes to the backend.
By the way, can you use Undertow as a load balancer?
That's the feature that's actually coming in 8.2. So you could use Apache HTTPD with mod proxy, which is shipped with Undertow, which works with Undertow actually. But now you can use Undertow as a reverse proxy, so you don't need Apache HTTPD as well. That's coming in 8.2.
That would be like less products that you need to use, because if it's very efficient, then I don't see why wouldn't you use it as a
Exactly. That's the idea.
But not there yet.
So then the other configuration is, let's say you don't have database goes away. You want to use InfiniSpan as a persistence mechanism, which is that beautiful blog that you wrote earlier, a few days ago. So you want to use InfiniSpan as a shared memory across your cluster. So across all of your WildFly instances, you got a shared memory. So everything else stays the same. Browser goes to load balancer, load balancer goes to WildFly, and all your session information is stored in InfiniSpan. So think about like 5 machines with like 20 gigs of memory. Then you got 100 gigs of memory as a shared memory where your session information is stored. And now InfiniSpan, you can say, by the way, go store it into the database, whenever you want to.
And there you can use replication or distribution, so you can configure it in a different manner. So if one of the servers die, you will still not lose any memory any data.
Well, that's the whole reason of you can give a hint. Like in WildFly, there's a concept of J groups. You can say how many nodes the information should be replicated to. Take it to a different level where you can say, oh, you know what? We were talking about moving your different services to different layers. So you can say, hey, WildFly is my application scalability,
application logic
scalability. InfiniSpan, I want to take it to a different tier altogether. So for example, we have this product called as JBoss Data Grid, by which what you can say is all my session replication is a separate tier. So I'm going to outsource, so to say, to JBoss Data Grid. And in addition, I'm going to still do my database replication. You can configure it in different ways where your InfiniSpan could come before your database, or InfiniSpan could sit in parallel to database. It basically goes by what your application needs and demands are.
So about scaling Vaadin specifically, well, one thing that usually Vaadin developers, when they are making it for just one server and for servlet servlet container only, then Vaadin developers tend to use like a static files as their persistency mechanism. That's something that should be avoided. It's easy to do, but in a real clustered environment, that pretty much doesn't work. So if you have some database data that you need to store, use the database. It's very easy with Java EE7. You could just use JPA, and the JPA is provided by the servers, so that's very easy to use. You can use InfiniSpan, or then if you need some messaging, then you can use JMS.
And in general, Java EE environment, yeah, it has its pros and cons, but it's known to scale pretty well.
Yeah. And one thing with Vaadin is I'd favor sticky sessions, because Vaadin is a server-side framework, so there will be some stuff in the session, and especially if you don't optimize that well, the session might become larger than in, for example, in REST applications where there is no session at all. And moving these sessions from server to server might start to take some time.
Right.
So that's why if you are using sticky sessions, then you don't need to move the session or replicate the session information that much. I think it's pretty much with all server-side technologies.
Right. So this is more like a standard that you're recommending for load balancer.
Yeah.
So that the sessions the request keeps going back to the same server.
Yeah, right.
Exactly. But the first one was in the Vaadin application itself.
Yeah. And of course, if you want to make the sticky sessions and session failover to work, then you must make your UI classes serializable, because the UI classes that you write, they will be stored in HTTP session. So, and the last thing I collected here is concurrency issues, because Vaadin applications, they are typically quite interactive. There is lots of third-party processes that kind of notify Vaadin applications or the Vaadin UIs. So there will be non-HTTP threads that will spawn some events, and then especially now with server-side push, those events are given straight for the end user. So there is lots of concurrency development, and that's never easy. That's very hard. So you need to find the right algorithms, right locking, and also right data stores. I have listed one example here, which we faced actually in our exercise. There is a big list of all active users in our exercise application, and then I used to make collections create synchronized list of these active users, and that doesn't scale that well if there is both read and write access to this object. So if there is concurrently some user interfaces are already being notified about an event, and then there are at the same time lots of new users coming into which are kind of added to the same list, that doesn't scale. But when I switch it to copy and write array, so that it only notifies those existing users that are there, and it's doing the looping like on a separate array, then it scales very well. It was a couple of hundreds of users that were on our tests, and with the synchronized list. And then the CPU was almost zero. There was almost no CPU at all, but the request started to take like ages. It was like 1 or 2 seconds, which is definitely too much for Vaadin applications. Yeah. But with copy and write, then it dropped down to some milliseconds.
So I guess 2 points that I would like to emphasize over there. First is JDK already has inbuilt structures. Now go look at the JDK concurrency utilities, and a lot of JDK concurrency API rather, lots of good utilities, so worth considering them. And second is test early, test concurrency early, test scalability early.
Yeah.
See what your real data set is, and then focus on that.
Yeah. And this optimization would not have come up if we wouldn't be testing it.
Exactly.
With 1 or 2 users at the same time, there is absolutely no issues. So let's go to the demo application. Well, we built a quiz application. It's a multiplayer quiz application, and there is an admin screen who is adding some questions, and then there are players answering these questions. And I think we can go to go to the actual application, I could first set the password. Now you cannot log into the admin screen anymore. And I have actually already raised a question there, and I'm wondering that who will be first in the quiz application and answering the right question.
So what you want people to do is go to the URL that is shown on the screen, which is vaadin-milestogo.rhcloud.com.
I could actually post this also to the forum page.
Yeah.
So in case you are there.
So go to the forum page. The link is live over there. So if you can log into the application, just go there and say, try to answer the question. And then what we can do is, in the background, we have an admin dashboard where we can see how the users are logging in.
Yeah, you could, for example, log in now, so we can see some active users coming up, and then we can also use.
So here I go.
Yeah.
Well, I'm going to go incognito first of all. So I go here to 8000, and I can log in as Arun, and it lets me log in. New question, a mammal living in Lapland. Is it Rudolph? Let me see.
No,
oh,
it was not.
10
okay,
second
but now we can
penalty
see that there are some users who are arriving here, and there are some answers. And
so I could possibly join in as another user here.
Yeah.
And let's say this time I join as Bob. That's the name. Oh, Bob won't work.
Yeah.
So Bob, okay? Bob Jr. How about that? Okay. So I log in here. And in my dashboard, do I see that thing going up? Yeah, there you go. Yeah. So it's going up. So here I say maybe I'm dumb. And I'm going to say Rudolph again. Oh, no.
It's still wrong.
So people are joining in.
Yeah.
And they're answering, and then down at the bottom it says the question has not been answered yet.
Yeah.
So, but
let's look at the video that I actually built about how we tested this application and verified that it really scales.
Right.
And we can discuss about technologies that we use there.
Okay.
So we had our test case, and we only managed actually to get about 10,000 concurrent users with WebSocket communication, but the fact was that it was because we were using Max as a server.
So you were able to scale up to 10,000 concurrent users against a single Vaadin app running on two WildFly nodes, front-ended with a HA proxy.
Yeah.
Okay.
So let's look at, this is the image about or graph about our testing setup. So we had 3 Gatling machines.
So what is Gatling?
Gatling is a load testing tool. I'm pretty sure that most of you know what is
JMeter?
JMeter.
Yeah.
And Gatling is pretty similar to JMeter, but the test cases, they are Scala code. So they are pretty easy to do. And why we are using Gatling here mostly was because it has an awesome support for WebSocket communication. So with JMeter, there is some kind of plugin on works with it works to some extent, but Gatling is really the tool that you want if you want to use WebSockets for your tests.
Okay, so Gatling and WebSocket is a good combination if you want to do scalability testing.
Yeah, and also Gatling scales very well. So because our application is pretty well scalable, then we will quite soon run out of resources on those machines that are generating the traffic to our application. So if we are using JMeter, we can handle something like 1,000 users, but with Gatling, we can easily lift it up to, let's say, 5,000.
So it's not just the scalability of your application, it's the scalability of your testing tool, which is equally important.
Exactly.
So pick the right tool.
Yeah. So
because you may think, hey, JMeter tested 1,000 and I'm good.
Yeah.
That's not right.
Yeah.
Go with what your data.
It might be right for certain cases.
Right.
I mean, for most cases, 1,000 is enough,
but
for some cases, it's definitely not enough.
Right.
Then we had a load balancer. And
so what was the load balancer in your case?
HA proxy.
HA proxy.
Yeah. So.
And then you had two apps.
These are our WildFly machines. So we just took some machines that we found from the office. These are actually used on our expos, these machines. And I installed WildFly there, put it in actually I used just a standalone mode, and started up, deployed the WAR file to both of those machines. And then I started in full HA mode.
So this is going back to what we were talking earlier. You could run WildFly in standalone or domain mode. You decided to pick standalone mode.
Yeah, I had just 2 machines, but if I would have had more machines, I would have definitely configured this domain mode.
Sure, that's okay. Because the point is, you need to understand whether you're using standalone or domain, you can configure full HA in both of them.
Yeah.
So what you did is standalone full HA.
Yeah.
Okay.
On both of these machines. And then they discover each other in the network, and then they use the same InfiniSpan memory, kind of, the shared memory.
So you had the HA proxy, which was basically acting as a front end to your InfiniSpan memory.
Yeah.
Okay.
So then we had a new switch, and then one Linux machine, which was acting as a HA proxy balancer. And then we had 3 Macs which were generating the context.
So this is the HA proxy dashboard?
Yeah, that's the dashboard for HA proxy. And these 3 machines are launching some traffic against the application. And now you can see some statistics on the HA proxy status page. And here. Now there are about 10,000 users arriving to these machines within 30 seconds. That's already pretty much arriving in so little time slots.
And that's
usually when you have lots of users, then they come every now and then there and do their stuff and then leave. But now in this case, we just used 30 seconds to ramp up the application.
So hypothetically, if in our webinar there are 20,000 people on our webinar and half of them join our website, that's the load we are simulating, because it takes people a while to type the URL, stuff like that.
Yeah.
And then it says, oh, you know what, 10,000 is a pretty real estimate in span of 30 seconds.
Yeah. And here you can actually also see on the lower left corner, there is a CPU meter. So now that there is lots of people who are arriving, then the load is at its largest. But it's actually still very usable, the application, because I fixed that one bottleneck. Then it's almost instantaneous. So if I click the button, then there was a server-side visit, and it was just some milliseconds, the response time, although there was quite a lot of load.
So going back to what we said is, profile your application,
Yeah.
figure out what the bottleneck is. You might be thinking it's a database, it might be somewhere else.
Yeah, but previously, before I made that optimization, that was the place where the latency might have been like 1 second. Then if you click the login, you don't know if it really happened or not.
Right.
Yeah. And this is actually an image from those Gatling machines, which are firing, or they have now started the WebSocket communication. So there is now 3 times 3,000 WebSocket communications to that cluster.
Concurrently within a span of 30 seconds. Yeah. So Gatling has the capability by which it can do that.
Yeah.
Okay.
And actually Gatling could survive with quite more. Actually the CPU and memory that was used by these machines wasn't that high, but we just couldn't figure out how to configure Macs for enough file descriptors. It was the problem that was here. It was for both Gatling machines and also those machines that are running WildFly.
So something that you would not think is
use Mac as a server.
But otherwise, you would think, all along is the problem in your application server, but it could go down as low as to your operating system, where you have to manage your file descriptors.
Yeah.
So you really have to get to your IT department or somebody who's well proficient in that configuration.
And also network might be the issue. You might have a bad switch, which is not able to handle enough traffic. We had a very good switch, that was not the issue. But then there is operating system, JVM, lots of things, buffers, these file descriptors. We were able to configure Linux, luckily. So we should have more Linux machines for this test case, actually.
Right. Well, Linux is good, and if you use Red Hat Enterprise Linux,
especially Red Hat Linux,
is known to scale very, very well.
At this point, let's rewind a bit. Now there is about 10,000 concurrent users, and now the load is very low.
So once they're logged in, then it's good.
Yeah. Vaadin uses quite a lot of CPU power when the user arrives.
Then the session is getting created, it's getting saved and all those things.
Yeah. But once the users are there and just suggesting some answers, then at that point, then it doesn't really consume anything. So it's very cheap for the web server when Vaadin application has started, because Vaadin is only transferring some changes like deltas for the UI. So if we, for example, if you suggest an answer and it says notification that was a wrong answer, we only change very small piece of JSON communication to the client-side engine, and there the smart client that's there running as a JavaScript, that kind of just displays the message.
Nice. So now when you ran this test, Gatling, what kind of results does it report back, and how do you visualize? So this is like a custom dashboard that you made?
Yeah, this was just our application dashboard, but Gatling actually creates very nice reports. It's using high charts to display and visualize the tests, and then you have also for each request, you can see what happened. And
okay, so do you have any local results captured?
Yeah, so this is image capture of that test run. So here you can see how the user count were ramped up. So this is active users here. Yeah.
And this is 3,000 because it's one machine.
Yeah, this is from one of those Gatling machines. If we would have been able to use just one Gatling machine, there would be 9,000 for these days. And here are response times. So more than 90% of requests were handled in less than 39 milliseconds. So it was very responsive during this test.
Do you also have a snapshot of a little bit more detailed data from Gatling?
Yeah, actually, I have. This is another run of the application. There is actually some errors also.
Oh wow, it's a very fancy dashboard.
Yeah, the reports are really nice to look at, and you can easily see what's really happening. And here you can also see that this is the part where there is lots of people entering their
this
names.
is logging in part.
Yeah, so there is some growth in the response times, but then during the normal operation, the response times are very, very fast.
And so that's very highly reflective of what a user application would look like.
Yeah.
So if you release an application, a lot of people log in right away, and then it's a low traffic going forward.
Yeah.
Specifically for our quiz kind of an application.
Yeah. Okay. So let's look at the quiz. Okay, somebody has 91 the quiz actually here. Let's make a short test against this deployment, and this deployment is actually in OpenShift.
Right, so what we did is we basically, now in OpenShift, you can easily spin up a WildFly instance, and you can spin it up in a scalable way. So if I can switch the screen over to my machine over here. And if we can show this machine. Okay, so now here we are. This is, first of all, you go to openshift.com, you log in here. You can create a free account very easily. And I have several applications created, but you can create a brand new application here. You can say, you can see there are lots of applications that can be very easily created using OpenShift here. The one that I'm particularly interested in is in a WildFly 8 instance. So I'm going to say, okay, I want a WildFly 8 instance here. There are different gears, which basically corresponds to different memory size or disk size. If I keep it small, which is okay, then I can say scale with web traffic. Just a simple command over here. And I can say create application. So literally with a click of button, you can create a scalable instance of WildFly. And what you get with that is multiple cartridges, and the cartridges are brought up on demand and scales down on demand front-ended with a load balancer.
Yeah.
So it's very easy to get started. Now, all of this, if you want to do this on your local machine, can be very easily done in a few minutes as well. But of course, you need to know how to create a cluster and all those things.
Yeah.
So that's the reason I was saying OpenShift is very easy to get started.
Yeah, it's much cheaper probably than to configure HapRocks yourself, because there is lots of configuration that you need to do, especially with these new technologies like WebSockets.
Right.
There are lots of issues still, like the file descriptors. You will need to adjust them if you want to really scale well.
Right. And in this case, you get by default WebSocket proxy automatically.
Yeah.
It's on a different port. It's not on 8080.
Yeah, it's on the beta testing level at the moment.
Right.
So it uses this special 8000 port if you want to try WebSocket communication.
That's right.
Yeah.
That's right. So it's very easy to create it. So what we did is we created this application. The application gives us a GitHub or Git repository. Yeah. We checked out the Git repository, put our WAR file from the quiz application, and that's it. The application was live for us then right away.
Yeah. Clock is ticking and we are actually already 10 minutes over our schedule, so maybe we should get to the questions at this time. I think there was some questions already filled in the comments, and here is one question from Petrus. What is your suggestion about CDI injected components and getting UI sessions serializable? I think this is mostly for Vaadin CDI add-on, which is currently it's in an alpha state. But I think if you have any issues with Vaadin CDI, then fill the tickets and be active with our development team, because it's currently under development. So in case you have some serialization issues, contact our development team immediately. Fill tickets and we'll find out the answers. Okay.
So there's a question by Mihail which says, can Vaadin app be scaled using Tomcat Tommy?
Yes, it can. But why would you use WildFly?
That's my point. So Vaadin applications are pretty agnostic. All they need is a servlet container basically.
Yeah.
But the WildFly application server makes a lot more sense because, with Tomcat it's pretty much plug and pray. You plug your own stack and then you pray it works.
Yeah.
With WildFly, everything is so well tested. It's a big company behind it. Lots of engineers who are working together to make sure it's a rock solid application server. With out of the box clustering, centralized administration, beautiful admin console, REST API, all the management capabilities, all those good things, and most importantly, the production support that comes along with it.
Yeah.
Completely optional if you want to use it, but at least you have an option.
Yeah.
So lots of good reasons for using WildFly for scalability of your Vaadin application rather than using Tomcat.
Yeah. And then Peter is asking why Vaadin and Java EE is a good combination. Well, why Java EE is generally a good option. That's the real thing. There is a lots of services that you can use with Vaadin. For example, JPA, you don't need to configure. If you are going with plain Tomcat, for example, then you need to configure that I'm using this JPA and I'm configuring in this manner and I'm handling my transactions in this way. But with Java EE, you have well-proven methods that you will be using. Everything just works. And why Vaadin, especially instead of some other, for example, JSF, which is included in Java EE specification, I'd say Vaadin is very good if you have lots of views, lots of code to write for your UIs. Vaadin is very developer friendly and it's very efficient to use. So if you have a large application, then use Vaadin. If you want to make a Gmail, then maybe not. Because with Vaadin, of course, it's a server side and it's using the session to store the application state. Of course, it's not as scalable as just plain REST calls. That's for true, but it's scalable enough for most situations.
Right. Yeah, I mean, you don't need to be a rocket scientist, to do anything.
Yeah.
There are lots of users who just want a decent application server, a decent UI framework. So this is a good combination for them. So Java EE offers you JSF and JXRS plus sort of JavaScript front end, and Vaadin is a good combination because it also removes the impedance mismatch.
Yeah.
You're using Java on the front end, Java on the back end, and that allows you to code your entire application using Java.
Yeah, you don't need to make a context switch when you are changing from developing your AGPs to Vaadin because you are all the time using Java.
Right.
Yeah.
So now, how would users get handled to this application and all our setup?
What?
How would users get hold of all of this application that we created, and the setup and the Gatling and the configuration and the slides?
We will be creating a couple of blog posts after this about using Gatling, for example. That's a big topic, and I will definitely want to write a blog post how you can use Gatling with Vaadin and WildFly. So that's, for example, one. And then the source code of this demo application, it's also in the GitHub, how you can publish that address as well. For example, the forum post. So there is one example script about Gatling usage as well.
Right.
So it's in the same project, but I'll definitely want to make a cleaner version also, where you can concentrate only on Gatling usage. But I think that's the biggest thing that we learned from here. That's now proven that technology works for load testing of WebSocket applications.
Right. So there are a lot of places where you want to customize your stack, whether it's the front end, whether it's the middle tier, whether it's the back end tier, whether it's your operating system, whether it's the file descriptors, whether it's at the network layer, whether it's at the switch layer. Lots of different places where you can customize this, where you possibly have to customize it in order to meet it. So for example, when we were deploying this application on OpenShift, we literally had to go into HA proxy configuration and change the number of file descriptors it can handle. So a lot of
there was a perfectly good setup for normal HTTP request, but when we were using WebSocket communications that keep on all the time for each user, then it was just not adequate enough. So after the configurations, it worked perfectly.
And then one of the blogs that I will do is, it seems like some of the people are not able to access the link. One of the blogs I will do is how you can easily deploy this application on OpenShift and run your own way. So that way they will have a custom application of their own, and hopefully they can learn from it.
Yeah. And if you have some more questions, you can still ask them on the forum. We can follow the forum afterwards for a few days. But I think we must quit from this day now because you have a next speak to do in about
so
1 hour.
We're going to conclude with the resources. So Vaadin.com is where you find all the latest information about Vaadin. WildFly.org is where you find everything about WildFly, forums, downloads, all of that. And then last but not the least, if you want to learn about Java EE7, there are lots of Java EE7 samples on GitHub. So the URL is shown on the screen here. So you can leverage that URL and use it the way you like it. So we hope you enjoy it, and thank you very much.
Yeah, and in case you happen to be in Turku, welcome to Vaadin offices in about 1 hour. Arun will be speaking about Java EE7 there. Okay.
All right, thank you.
Bye.
Bye-bye.